So the length of AB from A to B, the length of this formula can be simply explained by these two formula which we know. As you could see, there is a square root, and in beneath it within it is x squared minus x, the difference between x, the sum of the difference between x and y's. So the two things that could make up in what my thought process, what I believe is first the gradient of AB. So x y x1 x y2 x1 y1 x2 y2. Graphically, why we take the differences of x and y's is so that it won't have any doubt with its original point. So sometimes it could be 0, yeah, and other times it can have a different number, so there won't be any confusion in the origin point, you know. So we are dividing the y's divided by x, so graphically y divided by x, that's the gradient. But that doesn't explain this bit right here, because this doesn't follow that. Not getting the gradient. Next bit of our formula is the Pythagoras theorem. So you can kind of see the similarities. A squared plus b squared, as you can see, give us the hypotenuse, but remember to put the square root to get it. Just in total, this idea, I think, just looking at it glance, kind of you can see how it formulates this idea, but in no way, form, shape or form does, I think, have a major influence from here, but I think much over here. But the idea is that the differences, so perhaps from the original point there won't be anything, no confusion. So it could, you know, it could be 0, x could be that, so x1 could be either of those, and x could be, so we're taking the differences of that and, you know, making up for that to find the length of it. That kind of explains it, and hopefully that helps.